So in problem 7, we want to determine if these two lines if they're parallel, perpendicular, or neither one. Now look at the slopes. That's how we're going to tell. We're going to compare the slope. All right, and I'm going to say this. Well, you know what? I'm going to say it this way. Line 1 is parallel to line 2. All right, just some notation. The subscript just names which line. So line 1, the first line, is parallel to the second line. Okay, and it'll go like this. Either way, if the slope of line 1 is equal to the slope of line 2. Now what do we have here? Look at these slopes. All right, what we have is the slope. You know what? I'm going to call this line 1. I'll call that line 1, this line 2. You see? Slope of line 1 is negative 5/12. Slope of line 2 is negative 5/12. These two are equal, so these lines are, I'm just going to write this, parallel. Now in number 8, again, we want to know, are these two lines parallel, perpendicular, or neither? Now here's an easy, fast way to tell. See that first equation? Look at the second one. You double, you double, you don't double, all right? So you double, you don't double. Now if you triple, don't triple, or quadruple, don't quadruple, then they're parallel. Right, now that's a fast, easy way to tell. So I'm going to say that these are parallel, but then if somebody asks us to prove it, then we'd have to actually prove it. So I'm going to say these two lines are parallel. I'll just say it like that. Oh, I suppose I should write it. Parallel. Okay. Now, if I have to actually prove it, I have to show, all right, if I call this line 1 and this line 2, I would have to show, or I'm going to have to show, that the slope of line 1 is equal to the slope of line 2. So let's find each slope. Find each slope. So solve for y. So for line 1, we've got x plus 3y is 8. So I'll solve for y. I'll subtract that x, so I'll get 3y is negative x plus 8, and now divide by 3, we'll get y is equal to negative 1/3 x plus 8/3. All right, so there's the slope of the first line. There's M1. Now, for line 2, we have 2x plus 6y equals 12. So we're going to solve for y, so let's subtract that 2x, so we'll get 6y is negative 2x plus 12. I'll divide by 6, so we'll get y is equal to negative 2 over 6x plus 12 over 6. So y is equal to negative 1/3 x plus 2. Now there's slope 2, and sure enough, slope 1 is equal to slope 2, so these two lines, L1 is parallel to line 2, and there's the proof. Number 9 asks us to write the slope-intercept, write an equation. All right, as soon as I see that, I'm thinking these two templates, y equals mx plus b, and y minus y1 equals m times x minus x1. Those are the two templates that I'm going to use. Right, the top one is called the slope-intercept form. That's what we want to end up eventually. And the bottom one is called the point-slope form. Now, of course, we'd want to use the top one because it's the easiest, right? It's just substitute m and b. But what do we have m and b? Look over here. Here's what we know. The line passes through 8, 5. All right, well, we don't have b. This is not on the y-axis. We're to the right 8 and up 5. But the line is parallel to 2/5 x plus y. Now, we know this. Parallel lines have the same slope, and perpendicular lines, that's how I'll write perpendicular. Perpendicular lines have what we call negative reciprocal slopes. Now, don't worry about this. I'll show you what it means in just a sec. What do we have for the slope of this line right here? So the slope of this line, I'll call that M1. That's our first slope. So M1 is equal to 2/5. Now, the line parallel to that would have slope 2/5, but we're perpendicular. So the perpendicular line has slope. Now, negative reciprocal, so you take the opposite sign and flip the fraction over. So if I flip it over, I get 5 over 2 and change the sign. So to get the negative reciprocal, to get this thing right here, that negative reciprocal slope, all you do is just take your slope, flip it over, and change the sign. So I'll become 5 over 2, but negative. Now, I have this. I'm going to use y minus y1 equal to m times x minus x1 with, okay, m, I know m now, right? M is negative 5 over 2, and x1, the x's that we're given, now up here, right? We're given that it passes through this point, 8, 5. So x1 is 8. Oh, let me try that again. x1 is 8, and y1 is 5. Let's substitute. So we will get y minus y1, which is 5, equals m, negative 5 over 2 times x minus x1, and x1 is 8. All right, let's multiply through. Let's distribute. So we'll get y minus 5 is equal to negative 5 over 2x. Now, negative, right, I'm over here. Negative times negative is positive. Now, you got a whole number here. Just multiply the whole number by the top. So you get 8 times 5 is 40 over 2. We can simplify that. Y minus 5 is equal to negative 5 halves x plus 20. And then one more step. Let's add the 5. So we will get y equals negative 5 halves x plus 25. And this line is perpendicular to the given line. True or false? This line and this line are perpendicular. Well, you know, if an equation has only one variable, it's either horizontal or vertical. Now, this equation here is x equals 2. That means the line cuts through the x-axis. And look, if a line cuts through the x-axis, if it cuts through the x-axis, it's got to be vertical. All right, so this line here is vertical. And if it cuts through the y-axis like this one, right, this is y equals negative 4. So this is a line that cuts through the y-axis at negative 4. So I'll just draw it over here. If it cuts through the y-axis, there's the origin. If it cuts through the y-axis like this, okay, it's got to be horizontal. All right, so this line over here is horizontal. And what do you think? Vertical and horizontal lines are perpendicular. So let's conclude this is a true statement. So, true or false, this line is parallel to this line. Now, parallel lines have the same slope. So look at the slopes here. There's the slope of line 1, maybe I'll call it the first slope, and here's the slope of line 2, M2, and M1 is equal to M2, right? The two slopes are equal. That implies that the line 1 is parallel to line 2, and the statement is that determine whether the statements are true or false. It says that they're parallel, so I'm going to conclude that this is a true statement.